that what you want to say? How about, hi, I'm Brian.
And I'm Brent.
And we're from Erebus Solutions.
Team Erebus has 3 members, myself, Brian Padalino, and Rusty Eller.
Brent and I are co-located here in Rochester, and he has a home office that's really nice that I go over to often. And then we collaborate with Rusty online.
We each bring a unique skill set that overlaps, but we each have our areas of strength.
There were 3 hurdles, there were 3 of us. We each just took one hurdle in our area of expertise. I was physical layer getting data across the link. Brent was physical layer identification, and Rusty was doing a prediction. So we had discovered the Spectrum Collaboration Challenge just on the internet. It essentially had been talked about as the thing that Brent and I had been working on for 10 years together, which is wireless communications in harsh and contested environments.
SC2 is proving that radios can effectively adapt and achieve the needs of their users in a really dense, contested environment. Proving that that can be solved will allow for it to be deployed out into the real world and give users and network operators confidence that the devices that they're going to deploy are going to satisfy their customers' needs.
We believe that a bandwidth-efficient solution is the one that's going to be best.
Erebus is the Greek god of shadow, and we wanted to make our spectrum access be as non-intrusive as possible. So we enter and exit and achieve our throughput with a minimum amount of interference to others.
Erebus Solutions technology essentially adapts in frequency, bandwidth, and modulation to go and utilize the skinniest amount of bandwidth to pass an appropriate amount of data to its end users.
We wanted to be extremely efficient when serving user data and to optimize for holes that we perceived in the spectrum that other people couldn't take advantage of. It's more difficult to share in time than in frequency. As the previous regulatory attempts have shown, we need to be able to share in frequency at the millisecond level, not at the regulatory 10-year level. So we look like a very narrow radio signature compared to other radios that are out there. So we fit into spectral opportunities that others cannot.
In between other spectral components, there may be guard bands, which are, a few hundred kilohertz wide. Many other radio competitors, as we've seen, will not be able to utilize that space, whereas that's a couple of channels for us.
Technology to solve this problem is been challenging to develop because it is not merely a simulation. We have to solve this problem and do it in a way that's real-time, actually solving real representative user data. We needed to build a state-of-the-art modem, build the sensing and the observation techniques both from local radios as well as from the collaboration language, and then build smarter decision-making on top of it. So it's state-of-the-art on state-of-the-art on state-of-the-art.
It's so hard. It's so hard.
Sleepless nights.
Let's move on. We're going to move to Team Erebus. We're going to take a look at their first attempt.
The worst day for SC2 for me was the night that we submitted the container and we made that final choice of which weighting we were going to go, optimizing for payline or optimizing for the more general scenarios.
And usually they're in these very narrow bands.
They have huge blocks of spectrum.
They're like everywhere here.
Yeah, it took 3. The first one, there was some unexpected behavior on our part, but the second one, we came out of the gate and we hit the number we needed to.
And it's just flirting with it.
The ensemble was dancing just below the number that they needed to hit for us to succeed.
Ben, I blame the ensemble.
There were a couple times where it was just like 1 or 2 just below.
Now if the ensemble can do it!
The entire last 30 seconds, they're dancing around it, and I just, Collaboration is part of this competition because it is a key to solving the spectrum crunch. Providing a mechanism for independently developed radio networks to communicate is one of the key things that will allow for the solution to be deployable. SC2 harkens back to a lot of the DARPA grand challenges, in particular the autonomous vehicle. And you look at the autonomous vehicle and you can look out through the windshield and get a sense of what's coming up ahead of you. The SC2 challenge, you're trying to drive a car with the windshield blacked out. This spectral sense only allows you to look back in time, and you can never predict what's in front of you based solely on spectral content. The collaboration language allows for teams to predict what's going to come up in the spectral road. Collaboration has been very important to our success thus far. It allows us to properly find spectral holes. It allows us to prioritize the user data that we are serving to make sure that we are using a fair amount of bandwidth. It allows us to both yield spectrum to networks that have additional needs and take it from networks when we have increased requirements placed upon us.
Essentially, we look at the needs of what the network is, and then we predict out a couple of seconds into the future to say, we're definitely going to need this for now. And then we reevaluate every so often to tell everybody, you know what, we didn't need this frequency, or this plan didn't necessarily work out, and then we essentially stop reserving those frequencies.
Looking at our technology, I'm most proud of the unique factors that we bring to the various competition events. The bandwidth scaling and seeing every spectrogram that goes up, being able to pick out our team and be like, oh yeah, that's our answer, and it's very clear, and it's being successful is very cool.
Winning the final event would be validation that our philosophies are best. Hi, I'm Brian.
Hi, I'm Brent.
And these pretzels are making me thirsty.